Thank you, Dr. McMorris, and thank you all for having me back. You're going to hear some themes that are familiar to you. This is an extended version of the presentation I gave earlier. Thank you for your patience as we go through it. It's interesting just observing the difference talking about SRM to an audience in Jamaica on a hot day in July as opposed to in London during the winter. You should see the sadness in everyone's eyes in London when you talk about blocking out the sun. It's too much to contemplate. The SRM Governance Initiative grew out of the Royal Society's 2009 report on geoengineering. I worked at the Royal Society at the time, and it was the world's first major science policy report on the topic. And the Royal Society's report recommended, as you can read there, recommendation 5, the society should work with partners to explore stakeholder attitudes, and the society should work with partners to develop guidelines for governance. And so the Royal Society, my former employer, joined up with Environmental Defence Fund, which is the green NGO from the United States that Ada works for, and with TWAS, which is the World Academy of Sciences, formerly the Academy of Sciences for the Developing World, teamed up to start the SRM Governance Initiative. The goal was to expand the discussion of geoengineering, bring some clarity to debates around climate engineering governance, and this began with the publication of the SRM GI report in 2011. This was not an attempt to try and tell the world what to do about governance. We felt that that would be kind of premature. Now, this was an attempt to open up the governance conversation, so it addressed institutions, definitions, categories, goals, concerns. I commend it to you as a good place to start for thinking about SRM and SRM governance, but you won't find the answers in there. That's something that's going to have to develop over time. 2011, SRMGI moved into a new phase. We ran meetings in India, China, and Pakistan. 2012-13, we moved into meetings around Africa that I mentioned earlier. We co-organized an event at Berkeley in California, bringing together young environmental leaders from developing countries. The goal of this, as I mentioned in my earlier comments, was to expand the conversation. People in developing countries, for reasons Professor Taylor outlined so clearly in his talk, people in developing countries stand to gain or to lose the most from SRM. Typically they're on the front lines of climate change, but it's a problem they've done very little to cause. So we felt that the discussion would be better served by expanding it internationally rather than just holding it in the UK and the US. The goals and structure of today's meeting. This morning's more about lectures and perspectives. We'll end up with a question and answer session where you can drill us with some of the questions that have been coming to you. This afternoon it's going to be over to you. We're going to break out into small groups and discuss SRM, and you can vent vent frustrations that have come to you this morning. You can ask questions. We can work in 4 small groups to talk about the issues in some more detail because we want to know what you think about all of this. For now, this is a test I give every time I give a lecture on climate engineering. I've given it probably dozens of times, including to Nobel laureates. No one has ever got the right answer. So this is your chance for fame. Can you tell me what all of the people up there, or the groups of people, have in common? No, I'll tell you, there's still another room where no one's got it right. What they all have in common is that they all work on things, that they're not necessarily in favour of. Now, this is more than just a flippant digression. There's sometimes an assumption out there that people who work on solar geoengineering are in favour of going out there and making it happen. And speaking for myself, my colleagues who work on it, at least for the people in the mainstream research community, that's simply not true. What you've got is a collection of people who are really concerned about where climate change is going, but typically who, when they first started working on geoengineering, were horrified. Juan Moreno Cruz, you'll hear from in a second, but he was one of a number of academics who, when they first heard the idea, set out to try and prove that it couldn't help, that it couldn't work. And when their results started to come in, they were kind of shocked that there's a possibility that it might be able to reduce climate risks. Why are we talking about SRM? Well, this was outlined well in the last talk. I find this slide to be useful and horrifying. This is based on IPCC data, and this is how many years we have of current emission rates before we pass certain probabilities of achieving certain climate targets. So, for instance, you'll see at the bottom, if we want to achieve 1.5 degrees C with just mitigation, if we want to have a 66% chance, we've only got 5.2 more years of emissions at the current rate before we pass a 66 chance, moving to a 50% chance in roughly 9 years and a 33% chance in 16 and a half years. Scary stuff, and that's because of the lifetime of CO2 in the atmosphere. Since we gathered together here in this room this morning, we've collectively emitted, I did a quick calculation, we've collectively emitted roughly 2 kilograms of CO2, all of us, just by breathing out. Roughly a kilogram of that CO2 will still be around in the atmosphere hundreds of years after we've passed out of this room and passed out of this mortal coil, and it'll still be heating the planet. And so far to date, humanity has released 2.2 trillion tons of CO2 into the atmosphere. Now, I don't want to give the wrong impression. Mitigation, bringing those scales down, that's absolutely crucial, but mitigation only stops the rate at which things are getting worse. It doesn't do anything to deal with the climate risks that are baked into the system from the greenhouse gases we've already released to the atmosphere. So people are trying to work out what the risks are from the CO2 already emitted. There was some reasons, some big reasons for optimism from the Paris conference. There was the aspirational target of achieving 1.5 degrees C. There was the nationally agreed emissions cuts targets. If everyone managed to make the targets that they make the goals that they committed to in Paris, we'd come out somewhere around 2.7 degrees. The range of uncertainty for that is between 2.2 and 3.4 degrees. Some countries will likely make their commitments, others won't. Even if everyone makes their commitments, we'll end up at 2.7 degrees, hotter than the pre-industrial average. And at 2.7 degrees, we don't know how bad the impacts will be. Prof. Taylor just gave a really vivid illustration. We could we will see some degree of sea level rise, more intense storms, extra hot days, and so on. If we're really lucky, that will be at the lower end of our projections. If we're unlucky, it'll be at the higher end. So there's 3 levels of uncertainty in climate policy. There's how much CO2 we're going to release, as collectively as a species. There's how much warming that CO2 is going to cause, and then there's how bad the impacts of that warming will be. Now, some people say, come what may, we'll just adapt to whatever climate changes come our way. But there are some things that you just can't adapt to. I've never seen a serious proposal, for instance, for adapting a marine ecosystem that is threatened by rising sea temperatures. I've never heard a serious, apart from putting creatures into zoos, I've never heard a serious proposal for adapting most ecosystems in situ, where they first grew. There are some things we could adapt to, but we just won't, because we are imperfect. Roughly 1 in 8 people on the planet is malnourished, even though there's enough food to feed everyone. So there are some things that we probably could adapt to, but we probably won't adapt to. And SRM is, as has been mentioned, the only way for quickly stopping or slowing or reversing the rise in global temperatures. Now, I want to be absolutely unambiguously clear about this. Nothing of what I've said means that we should do solar geoengineering. But these are the reasons that are causing researchers to think, hey, we've at least got to take the idea seriously. We've got to think about it. We've got to talk about it. I'll run through SRM. That is Mount Pinatubo that I referred to earlier on in the day. That's Mount Pinatubo erupting just over 25 years ago in the Philippines. And that's what the global temperature record did for the years afterwards. You can see, mid-1991, following the eruption, the temperature went down by about half a degree Kelvin for the next year or two. And so scientists started wondering, is this something that we could do? Could we deliberately replicate this effect? As I mentioned, it's possible. This is at least we think it could be possible. This is a suggested way of delivering the sulfates to the stratosphere, the balloon and hose array. Other people have suggested that we could fly the sulfates up there, fly the sulfuric acid up there, and spray it out into the stratosphere. There are also proposals for cooling the planet by making marine clouds, the clouds over the ocean, brighter and whiter, and for thinning out cirrus clouds in the very high atmosphere to allow more heat to escape from the atmosphere. Some of the proposed approaches, as I mentioned before, it's probably in the region of billions to tens of billions of dollars per year to do this. Well, would it be a good idea is the question, and don't believe anyone who gives you a definitive answer on that. We just don't know enough at this stage. But scientists are trying to work it out. Here's a computer model that was run in 2008. This is quite a useful illustrative example. Don't take the specifics of this computer model run too seriously. The general patterns have been replicated by many different models under many different circumstances. The specifics, we don't yet have models with a high enough degree of fine modeling ability to be able to properly evaluate this stuff. But here we go. So on the left is modeling the global temperature. This is a world of 2 times CO2. This is a world of 2 times CO2, the same model run where the temperature has been cooled by SRM. And you can see there's not a single area of the planet that does worse under the SRM scenario. So this is where SRM is modeled to bring the temperature back down to what it was before. It's a similar but not quite as ideal picture for precipitation. So top right is the precipitation pattern in the world of 2 times CO2, where the world is allowed to warm up. This is a world of 2 times CO2 with solar geoengineering applied to bring the temperature back. Now, it's not as perfectly attenuated as the temperature is. You can see there are some areas where things get worse. So, in all of these comments, Professor Taylor mentioned the possibility of winners and losers with climate change. It'll affect some people more than others. That's the same with SRM. So even if globally SRM was positive for temperature and precipitation, let's imagine that Jamaica was one of the areas that received much less precipitation under SRM. I imagine that would be something that would be pretty bad for Jamaica and its ecosystems. How are decisions over whether to use SRM in this scenario made, particularly when these are just models? They're not a perfect representation of reality. They're just an approximation. So it's a question for you guys for the afternoon. How do we make those sorts of decisions? I'm sure you're wondering, what are the side effects as well? So it's projected there would be side effects. It's not yet understood well enough how badly they would be. So possibilities include the destruction, or at least the delayed regeneration of ozone in the stratosphere, if you put sulfates up there. Possible health impacts. People's lungs typically don't enjoy breathing in sulfur dioxide. And so health impacts are likely to get worse. We already put a lot of SO2 into the troposphere, the lower atmosphere. Putting more into the stratosphere would make that problem worse. Probably not an awful lot worse than it already is, because you wouldn't be putting nearly as much as up there, but we've got to take this into account. One of the main concerns for me is this termination shock. If you were using SRM to mask a rise in global temperatures, and then you suddenly stopped. If you're using it to mask a high degree of warming, as you can see in the top chart there. The top chart there is the world naturally warming up due to greenhouse gas emissions. The bottom chart is the world where SRM is used from the year 2020 to suppress temperatures. Then something goes wrong in 2060, and the temperatures suddenly spike upwards, because the SRM is only masking those greenhouse gases. It's not doing anything about them. Now, there's some reasons to believe an SRM system would be fairly robust against the things that might knock it out, that might disable it, but that's a serious risk, because warming of that speed gives far less time for people, for human systems, for natural systems to adapt to the new conditions. In all of this, though, I've talked about some positives, I've talked about some potential negatives. In all of this, the big word is uncertainty. We just don't know enough to be able to make good decisions at the moment. So take everything I've said with a grain of salt. The scientists are modelling, the social scientists are trying to understand the results, but there's still huge uncertainties that are out there. And of course, the science is only half the story. People, myself included, are every bit as concerned about the political impacts. I mentioned earlier the prospect that geoengineering will distract politicians from the task of cutting greenhouse gas emissions. I think that's a serious risk. People have suggested that research into geoengineering could prove a slippery slope. Once you start researching it at larger scales, you get momentum behind that. You get people who want to keep going with it. You get political capital, financial capital invested, and people might progress from research to deployment, bypassing societal concerns. And as I keep saying, who makes the decisions about SRM? Who gets to make a choice over a technology which is essentially global? I'll finish with a word about the politics. This is the area that's closest to what I work on. I work on governance. But even if the science tells us that SRM would be extremely helpful, we cannot wish away the tricky political dimensions. So let's think about it. What happens if China were to deploy solar geoengineering unilaterally, say? Pick on poor China. I've got no reason to think that they would do this. It's just an illustrative example. What happens if China were to deploy solar geoengineering, and then India were to experience a flood or a drought of the kind that Jamaica's been experiencing? These things happen naturally. We know that. Some people in India would doubtless think that it's caused by natural variation. Some people would think it was caused by China's geoengineering. What happens then? Do we get war across the Himalayas? Do we get international tensions? This is tricky stuff. Even let's leave side effects to the side where they belong. Even if SRM work perfectly. How would you get agreement on where to set the global thermostat between Canada and Russia, up there in the north, they might like it a bit warmer, and equatorial Africa, or the small island developing states of the equatorial region? How do we get that global agreement? And then given all these pressures, given the threat that climate change very clearly is, particularly to small developing countries who've done nothing or done relatively little to cause it, does that give them the moral right to use SRM? What happens if, say, Bangladesh got desperate and decided, I'm going to deploy this unilaterally? We have the moral authority, we've done nothing to cause the climate change, but we're suffering disproportionately. Well, could we see unilateral deployment? Some people say yes, some people say no. The traditional tools of statecraft could be used to deter a unilateral deployer. And they say, well, perhaps we'll get coalitions. We'll get a coalition who come together to say, well, we're going to do solar geoengineering. We have the moral authority. But what then stops another coalition popping up to say, well, we oppose you, or we want to actually do it more than you do? And so many people think, well, okay, the answer to this is through the UN system. Before we were to deploy solar geoengineering, you'd want a consensus vote in the United Nations, 200 or so countries agreeing. But how do we get agreement between 200 or so countries on even whether to deploy this, let alone what level to deploy it to? And so here's a question for the afternoon. If there was deadlock at the United Nations and they could not come to an agreement about solar radiation management, we go back to square one. What's to stop a country from just unilaterally going out there and saying, well, we're going to do this because it's in our national interests? So those are questions for you for this afternoon. And I'll leave you with a thought. It's interesting hearing people's opinions on solar geoengineering, on the politics, where it might go. For a lot of people, they think the country most likely to deploy would be America. And that comes up quite often in conversations because they see America dragging its heels on cutting their emissions. They see a very strong climate denial lobby in the United States. And they think, well, America could be set to use solar geoengineering as a way of skipping out the way of cutting emissions. Other people, though, have said, no, actually they think the first calls to use solar geoengineering are not going to come from America, because America, relatively speaking, is relatively insulated from the effects of climate change. It's a rich country, it's got money for adaptation, building large seawalls, changing its agriculture and so on. So some people suggest that it's developing countries, small island developing states, that are more likely to make the first calls to use solar geoengineering. These have both been suggested in the debates. There's no right or wrong answer. So that's the kind of thing we want to discuss this afternoon. But that's what I'd be really interested to hear your opinion on. Where do you think this is going? Research governance, and even the possibility of deployment. I think I'll leave it there. I was going to repeat the 5 main messages. I think I've hammered them to you enough, so I will thank you for that and look forward to speaking to you this afternoon.